Here's a third type of transformation. We've done translations and reflections, and now we're doing rotations. So rotation is a turn around a fixed point called a center of rotation. And the figure rotates at a specific angle and a direction. Now with rotations, we automatically rotate counterclockwise, so that would be this direction to the left about the origin, unless it says something otherwise. So sometimes it will just say to rotate it, and then we know we're going counterclockwise. Remember, clock goes this direction around, so if you want to go counterclockwise, you have to go around the opposite direction. If we see that we need to rotate our figure 90 degrees counterclockwise, that means if we look at our picture close enough, you can see the A and the A prime letters on there. So we're going to the left, so it starts in quadrant 1, and now it's in quadrant 2. And we have a specific rule. So we take our XY values, and our Y value will now be in the X location. We're going to make it a negative because now we are coming over on this side. And we need to move on to the quadrant, quadrant 2, because it goes 1, 2, 3, 4 like a C. And then our X value is now going to be in the Y location for the 180 degrees. So that would be 2 sections of our graph, or 2 quarters of our graph. And if it starts out as X, Y as the original coordinate, now we are just making both of them negative. So negative X, negative Y. The third way is if we go 270 counterclockwise, think of that's 3 90s, so 3 sections on your graph. And it starts as XY, and the rule makes the Y go first but keeps it the same sign, or positive sign, and your Y then becomes the opposite sign that it started with. So what we need to do is we see it's 90 degrees counterclockwise. Let's write down what our rule is. So we know it needs to be a negative Y and then the X. First off, let's graph our coordinates. What you do need to understand is that you should be able to pretty much predict where your picture should end up with the degree of rotation. And the easiest way of doing that, if you think about our graph all the way around in a circle, is 360 degrees. If we divide that by 4 pieces, that's 90 degrees each. So if it starts in quadrant 1, my picture should end up in quadrant 2. Because I'm moving 90 degrees. If I was moving 180 degrees, if I start in quadrant 1, I would end up 2 rotations around because 2 90s gives me 180. And if we had 270, if I started here in quadrant 1, I need to move 3 sections around. Now realize that if we wanted clockwise 90 degrees, and I started right here, I'd be moving this direction. So I'd end up in quadrant 4. And 90 degrees clockwise is the same as 270 counterclockwise, because think of where that figure is going to end up. So up above, why don't you write that next to 270 degrees counterclockwise, and with our 90 degrees, that would be the same as 270 clockwise. If you are wondering, what about the 180? Because if you think about it, if we move counterclockwise or we move clockwise, we'll end up at the same location. So with that one, it's the same no matter which direction you move. All right, so going back into number 1, if we start with our purple coordinates here and we need to move them clockwise 90 or counterclockwise 90 degrees, we know we'll end up over here. So if for some reason my picture ends up down in quadrant 3, I know I did something wrong. That's also why you want to know the direction that you moved. Now, if I know my A value, or my coordinate A is 2, 7, X is my 2, Y is the 7, but now I need to have the negative Y. So my Y was 7, now it's going to be a negative 7. And my X was a 2, so I'm putting that as the last location. So this is negative 7, positive 2. If we do the same thing for letter B, we have our X and our Y. I know that my Y needs to go first, and it's going to be a negative Y, so that would be a negative 5. If it was already a negative 5, it would make it a positive, so it's just changing the sign. Then my X value stays the same. Next, so I'd have a positive 6. Lastly, I've got my C, and we have our X and our Y, so I need to make a negative Y goes first, and then a positive X. So negative 1 and positive 4 would be where my C prime is going to end up, and then we can connect those points together. I also labeled on there which is my pre-image, which one is my image, because we had to graph and label it. I didn't have to write that, but I just wrote that just for you. We are going to jump down to number 3, and we are moving this trapezoid. So we've got 4 coordinates this time. We are moving it 270 degrees counterclockwise. So remember, counterclockwise is this direction around, and we need to move 3 of the 90s. So that'd be 1, 2, 3. I know my answer will end up in quadrant 4, and our rule that we had written up above is y negative x. So for each of our coordinates, we can move them. And if you think about where that's going to end up, that tells me that I'm going to have a positive value and then negative. So you can check your signs too if you can't remember the signs, versus this last one was a negative first and then positive. So that gives you quadrant 2. Now for the actual coordinates themselves, if we do our j, we have our x and we have our y. So the y goes first and it stays the same. The x value goes next, so that's a 3, but it needs to be the opposite of that, so it'd be a negative 3. So 4, negative 3. On letter K, I want you now to do this one yourself. All right, so the y value should go first, and it's still a positive. The x value then changes to a negative, and now it's in the y location. So 4, negative 6 would be right here. Our point L and point M will end up at our 1, negative 1, and then 1, negative 8. So one thing you have to remember is you need to start making some flashcards of the direction and then the rule of where those coordinates are going to move to. We are going to jump all the way over to the back side of your paper to number 10, and this one just says 180 degrees, and that's because, remember, it doesn't matter which direction you go if you're starting a quadrant or starting anywhere. If you move halfway around, doesn't matter if you go counterclockwise or clockwise, you will end up at the same location. So that's why there's no direction with 180, because it doesn't make a difference which direction you go. All right, so for our rule for 180, we are going to have our negative x, negative y is our rule. So the x and y stay in the same location, but we're switching the signs. Now for our picture in number 10, I wanted to do one that wasn't necessarily starting in quadrant 1, so you could predict where it needed to go. So you can think of each point individually if you want to. So point X is in quadrant 4, so if I move it 180 degrees, I go 90 and then 90 again. So my X is going to end up somewhere right around here. Y then, I would move 90 and then 90 again. My Z, so X and Y are going to end up over here somewhere. My Z is in quadrant 3, so when I move it, that would be 1, 2 times. So that's only going to get to quadrant 1. And same with W, since they're starting in the same location, in the same quadrant. So we're going to have 2 coordinates here and 2 coordinates here. Now, to start us off, let's do our point W. So that's our X and that's Y. Remember, they stay in the same location, but the signs change. So since the X is a negative 3, now it is a positive 3. The Y was a negative 5, and now it is a positive 5. So we have 3, 5. Now if we do, let's do the X next. So X is at 1, negative 1, so now it's going to be a negative 1 and then positive 1. And remember, we said that was going to end up in quadrant 2, and it does. So that's our X prime. All right, I want you to do now these last 2 coordinates. Your Y should get a negative 3, positive 3. Your Z should be a positive 1, positive 7. Remember, the biggest thing is to set up 3 flashcards, one with each of the directions and the degrees, and then your rule that is on the back side.